Assalamualaikum, we want to present our linear algebra 2 video presentation. The title, Solving the Data of Influenza and Pneumonia Date Cases in United States from 1995 to 2019 by using Excel. So these our group members. First, Maizatul Anisa binti Muhammad Khairul Anwar 2024917513. Second, me Antasha binti Azhar 2024978079. Third, Muhammad Mahathir bin Ahmad 2024767095. And the last one, Muhammad Khairul Ikhwan bin Ismadi 2024977829. So this our content. First, introduction. Second, problem statement. Third, objective. Fourth, methodology and appendix. And the last one, conclusion. In 2019, influenza and pneumonia caused approximately 12.3 deaths per 100,000 people in the US. These illnesses are significant contributors to mortality, accounting for about 1.6% of all deaths in the country in 2020. Influenza, commonly known as flu, is a highly contagious viral infection prevalent, especially during winter season. Although flu frequently leads to pneumonia, the majority of flu cases do not progress to pneumonia. Pneumonia, which involves lung infection or inflammation, poses a particularly high risk to young children and elderly. Influenza is widespread in the United States, with an estimated 35 million cases reported during 2019 to 2020 season. There are several flu symptoms such as cold, fever, runny or stuffy nose, sore throat and headache. These symptoms can range from mild to severe, sometimes necessitating medical attention. In the 2019 to 2020 period, there were approximately 16 million medical visits related to influenza in the US. Based on the data we choose, we aim to explore the predicted relationship between the year 1995 to 2019 and total deaths by influenza and pneumonia in the US per 100,000 population. We took 25 data as our data. To do this, we will use the least square method, a form of regression analysis between data points. In our study, year will be plotted on the horizontal axis and total number of deaths by influenza and pneumonia in the US per 100,000 population will be plotted on the vertical axis. So this the data we choose. Year is X and total deaths of influenza and pneumonia in the US per 100,000 population is Y.
The second topic is problem statement. These are a few problem statements that we can gain related to analyzing a situation between the year and the total number of deaths caused by influenza and pneumonia in the US by using the least square method. The first one is trend analysis of influenza and pneumonia death. To examine the pattern of death caused by influenza and pneumonia in the US across the previous few decades, aim to ascertain whether the annual death rate is statistically significantly rising or falling by applying the least square method. The second one is predictive modeling for influenza and pneumonia mortality. To create a prediction model with the least square techniques to estimate the number of influenza and pneumonia related deaths in the United States for the next decade and then verify the model using the past data. And the last problem statement that we can gain is seasonal variations in influenza and pneumonia death, which is to examine the seasonal patterns in the number of deaths caused by influenza and pneumonia over several years, and apply the least square method to identify and model any significant predict trends.
Okay, for objective, the first one we want to investigate the predicted relationship between the year 1995 to 2019 and the total number of deaths caused by influenza and pneumonia in the US per 100,000 populations by using least square method. The second one, to identify the risk decreasing, increasing or stable trend in the rates over these years by the graph of the data in the Excel.
Assalamualaikum warahmatullahi wabarakatuh. I am Muhammad Mahathir bin Ahmad. My matrix number is 2024 767 and 095. I will tell you about the methodology. First thing first, we need to find the equation of the curve by using the least square method. Using the quadratic model, which is y equal to a plus bx plus cx square. So first thing first, for step 1, we need to set up the matrix for m and y. In the matrix M, the first column, we need to put the 1 number for each row until 25 rows, and then the column 2, we need to put the year from 1995 until 2019, and then the column 3 for M is we need to square the year from the column 2, and then Y, for matrix Y, we need to put in the data from previous, which is the total death from influenza by per 100,000 population. Then we need to design the the matrix before to the equation mv equal to y. Step 2, we need to formulate the normal equation in order to find the v. Which is the equation is m transpose m. The first equation is m transpose times m, matrix M, times with v equal to m transpose times with y. Then to find the v, we need to put the m transpose m to the right side by inverse it, which we get the equation v equal to m transpose m inverse times with m transpose y. After that, we compute and calculate the m. First thing first, we need to compute m transpose m and m transpose y first. After that, we find the m transpose m inverse and then multiply it with the m transpose y, and then we can get the v solution. Then the final answer for v is the first row is 188108.483. The row 2 is negative 186.59399, and lastly the row 3 is 0.0462768. Then we formulate the equation for the best fit quadratic line from the quadratic model before, which is y equal to a plus bx plus cx square. Then we put in the value, we get y equal to 188,108.483 minus with 186.59399x plus with 0.0462768 x square. After that, we need to find the error vector and the magnitude for this error vector, which is error vector equal to mv minus y and the magnitude of error. So step 1 is we need to find the mv first, which we need to calculate the matrix M with the times with matrix M with the value of v that we get before this. Then use the information to find the error vector by using formula E equal to mv minus y. From the E value, we go to the step 3, which to find the magnitude of the error vector. Using formula magnitude of error vector equal to square root of E1 square plus E2 square plus E3 square until E25 square. And then we get the last answer for the magnitude of error vector is 8.82946.
This graph is a representation of a quadratic model showing the relationship between the year and the death by influenza and pneumonia in the US, where the x-axis is represent as year and the y-axis represent the death by influenza and pneumonia in the US. Generally, the data shows a downward trend from left to the right, indicating that the death by influenza and pneumonia in the US decreases as the year increases. This curve shows a non-linear relationship where the change in the death by influenza and pneumonia in the US decreases as the value of the year increases. From this graph, we can predict for the next year, maybe 5 years later, the death by influenza and pneumonia in the US will be decreased. This graph is a residual plot that shows the residual of quadratic model around the x-axis. Residuals are the differences between the observed data points and the value predicted by the model. The residuals are scattered around the x-axis with both positive and negative values. Overall, the residual plot helps assess the adequacy of the quadratic model. The scattered nature of the residual around the x-axis without a clear pattern generally supports the appropriateness of the model, though some areas indicate potential misfit. First, we should write the matrix M and value of Y in the Excel, and then we find the matrix M transpose, which is we write the formula equal to transpose, and in bracket we highlight all the matrix M. Then we find the matrix of matrix transpose by matrix M, which is we get the matrix 3 by 3. Then we find the matrix of matrix transpose by the value of Y, and we get the matrix is matrix 3 by 1. And then we find the matrix inverse of matrix M transpose by the matrix M, and then we get the matrix is 3 by 3. And then we get the value of V, which is formula of matrix inverse of matrix transpose by matrix M, and time by matrix transpose by matrix Y. And then we get the matrix of matrix M time by the value of V, and we get the matrix is 25 by 1. Same goes to the error, which is formula of error is MV minus Y, and we get the matrix is 25 by 1. And then we get the magnitude of error, which is square root of all of the error, and then we get the answer 8.82946.
So, the conclusion that we can conclude from these cases is there are a few types of best fit curve that we can use to fit the chosen data. Based on the investigation that we have done for these cases, we use least square fit of quadratic polynomial as the best method that can be used to find the best quadratic curve to fit the data. Least square solution is employed when a system of equations is overdetermined. Best fit curve is determined by using the least square solution to approximate a set of data points by minimizing the total square distance between the curve and the data point. Hence, the error magnitude that we can obtain for these cases data is 8.82946. So, we can conclude that this quadratic model is suitable as the best fit curve that can fit the data for our cases, which this model gives us the best approximation for these cases.